All right, well, welcome back from your busy night. I know it was a rainy Halloween night, so hopefully you didn't get too much sugar in you. So yesterday your goal was to write it. Today your goal is to do it. So we're writing it yesterday, and now we're going to do it. So write it, do it type of a process. The conversations yesterday that you were having about title and purpose and what's background and what's not background and procedure and all of those different conversations that you were having, whether you realized it or not, you were actually learning as you were doing that. Okay, you have a lot better idea, and you probably won't know until you get into the lab how this is all going to play out. But now you at least have been exposed to the 4 types of tests that you're going to be doing, or the several different types of tests that you're going to be doing. And the fact that you are then going to, once you get all your test results, you're going to go ahead and mix with some other groups and make sure that everybody has the same information. So I'm going to allow this. 1 procedure per group will be allowed in the lab because we don't need all these lab notebooks in the lab. So you'll be able to choose in your group the lab notebook that you want to take in there. The other thing that I want to show you in the lab that's different today is there's going to be a couple of green pens back here. And the reason these are here is if you are doing the procedure and you wrote it one way, you thought about it one way, but when you actually get into the lab and you see what the tests are all about, you can take a green pen and just draw a straight line through what you did and make that correction or add a step or put something into the margin without your lab report looking too very sloppy. And then don't feel as though you have to rewrite the lab when you turn it into me. And I don't think we'll have this due until Tuesday, so we'll have some time. Yes, I know, Cole's excited. So please take advantage of this as a group. You want to discuss this as you're going through the procedure. Maybe we should change this, or perhaps that should be altered a little bit. But don't go crazy on it, rewriting the whole entire thing. Okay, this is not where you're going to write your lab. I mean, you have a procedure already. You're not going to rewrite what you've already done. You're just going to kind of annotate it a little bit. All right, I want to also bring your attention to a couple of safety rules today. We're going to have to get goggles out of the cabinet there. So what you're going to be doing today is you're going to have the qualitative tests that are up on the board. We've talked about color and appearance. Solubility. The water solubility you can do at your lab bench. The hexane solubility is going to be done in the fume hood. Okay. The conductivity is with these conductivity testers. They're already plugged in, and so you're going to bring, I'll put a larger beaker here, but you're going to add your water and whatever your substance is, and you're going to test it with the conductivity tester. Do you remember when we used this for the electrolytes? We put this in, and light went on. We did salt water, and light went on. You didn't, I did it. That's why you don't remember it, but I did it as a demo. Okay, so these things are live, and the plastic coverings on these electrodes make it safer for you to use it. But when you put this in, you kind of have to move it around a little bit to see if you get a result. You'll know if you get a result if it conducts electricity, if what happens. The light goes on. Okay, so there's 2 of these, so we can have 2 people going at the same time. The deionized water that you need is here. I also put deionized water at all your lab stations. And then the last part, the pH, the sodium hydroxide, hydrochloric acid, all of those can be done at your lab station. There are test tubes already there at some of the lab stations. There's extra test tubes here. 8th period did this part of the lab yesterday, so we need to make sure we clean out all the lab equipment. Distilled water, make sure you use your test tube brushes and all that kind of stuff. All right. Okay, the last thing then, once you get through all your tests today, you're going to earmark 1 person to go and travel to the other 4 groups and make sure that you kind of match up with your data tables. And then once you do that, then you'll be ready to move along. The dextrose has been replaced, so don't worry about it in your lab. You're going to have your 2 knowns are going to be copper 2 sulfate and paraffin. Those are your 2 knowns. And then the other thing is you're only going to do 2, not 4. So you're only going to do 2 knowns, not 4 knowns. And then the last thing is for the melting point. Since we don't have this due until Tuesday, I'll have you look that up tonight. what the melting point of ionics are and what the melting points of covalents are, so we won't be doing that particular test. Okay? Everything else you should be able to do. Go ahead.
Where's the paraffin?
So where are we at on our procedure? Tell me what you're doing and where you're starting. Solubility would be next. Okay, so that would be a green pen kind of thing. Just cross that off.
So where's the paraffin?
The paraffin is, it's a candle. You'll have to get it from the side. Over there in the white tray.
Yeah.
Okay, so you're going to do observing, not melting point, solubility, two solubilities, conductivity. Okay. All right, so when you say place each of the known chemicals in a solution, what else do you have to qualify about that statement? Let's say sodium hydroxide solution. Place each of the known chemicals in a sodium hydroxide solution.
The amount.
Amount would be a good thing. What else would be a good thing? I saw this and it just said place known chemicals in a sodium hydroxide solution. So here's a known chemical and here's sodium hydroxide solution. Place them.
In a beaker or something.
Okay, so you have to qualify that. Where are you going to place them? All right? Okay. And you don't have any of that written down? You didn't take a picture?
What she did was we were supposed to do it on the Google Doc. She said she was going to write it down. But I have the Google Doc for proof.
Does she have the Google Doc? Is it on the Google Doc?
No, she said she had it.
But does she have a Google Doc done? Is there a way for you to get the Google Doc and print it?
She doesn't have it done. She said on the Google Doc that she would do it on
She said on the Google Doc she did. Okay, you guys are going to have to go back also. Okay, that's fine, but I don't think you need 6 people to do that. So figure out some others. Go back with your procedure, divide up who's going to do what test so that you can maximize your time. Okay? That's why you wrote your procedure the way you did. Sure, you need a
It's yes and hexane and no one alcohol. It was 7 solubles.
Just put a stack.
Alright, conductivity. Alright, someone should start the paraffin. Someone should do the paraffin.
Wait, was hexane was no? Or yes?
Alright, someone should.
I can do it.
I can help you out.
Okay. So,
Did you do solubility?
I'll still
Solid.
solid.
Solubility and water.
Yeah. Make sure it's
It's kind of.
crush. Do we need to crush?
We've got what? Okay, we've got pH solution.
What do you think you're doing?
No,
I think
we
we might have to
use it
crush
over and over. We use solubility. Then you have conductivity.
Yeah.
We can, yeah, conductivity. Reality, one test, testing different.
Right.
Get to 70.
You want large scoops.
For the wax,
You can, yes, you can crush it or shave it. You can use the scoopula to do that.
oh,
And you can get a piece of paper to do that. Okay, but you need to get a scoop. We have one by your desk.
Yeah.
Okay, go ahead and bring me your beaker that has a copper 2 sulfate in it.
This one does, but it's
No,
just...
the dry version of it.
Oh, okay.
Yeah, go ahead and take it from there. And scoop, you don't have scoop. That was all right, so you want another pretty good size scoop of this. You're gonna have to move it around a little bit, Doug, and make sure that it's dissolved. Did you stir it?
Yeah.
2 large scoops are in there, or just 1 scoop?
Like one scoop.
Okay, read the directions.
So I don't have to press anything. I just put it
You
in.
just put it in, right?
So you measure pH and like test it.
Kind of move it around a little bit.
Yeah. So
So you might want to pick it up. Or not. Yeah. You might have, is that 30 mils of water? 60. Oh, it's 60? Then you need to put 4 scoops in there. Because notice it says at 30 to 35 mil. Okay, they're large, so. Now let's wait until she puts more in there. Alex, was it on there? Okay, well then keep writing.
To make up the lab, should come in after school.
No, you just have to keep writing and get somebody's data. There you go. See what happens when you follow directions? Nicely done. Okay, that waste beaker can go over here. You guys don't throw anything down the sink. Waste beakers are labeled over here for whatever you need it for. Now, are you guys doing
We're doing both.
paraffin conductivity?
Yeah.
Okay, so we'll have to.
Do we need more?
The paraffin is as essential of measuring as the other stuff is. So that is your paraffin.
Well, we need like this use.
You have to keep at your desk. All your cards are at your desk. Sorry. That work well? Oh, it is next. Good job. Pardon me? Copper 2 sulfate. It's one of the knowns. CuSO4.
Okay. Right
Are you
here.
closer to being done?
Yeah, I'm always writing it down.
Okay.
I just want to say
Because even if you just each did a part of the procedure, then you would be done quicker, so that you could at least get some of the lab finished.
It's not like they loaded it on me. That'll be cool.
Yeah, me and Cole just did the same. Where you closing then?
Here, fine. Then let's write down the first few steps so we can get started on the lab. While Mark finishes the rest.
Is there a procedure piece that you could at least get started
Yeah,
on?
that's what I just said. We're gonna write down the first few steps so we can get started.
I already got most of the stuff.
Okay, because I'm concerned that you're not going to get good data here because you didn't think this through enough. And so I want to make sure that you do, as you're getting at least one piece of the procedure finished, that you at least go and get, not all of you, some of you need to stay back and write the rest of the procedure.
I just need to let you guys know.
So,
Oh, we're screwed.
Got your goggles in there? Okay, how close are we? Are you doing, have you done anything?
Yeah. So we're just kind of trying to figure out, like,
So what happened yesterday? Why, I don't understand that there's nothing written down.
like when
Explain.
we put everything in the Google Doc, and she was just like,
and
I'll
we,
put it just in
like we typed on, I typed up like the materials,
Okay.
and we each did the pre-req questions so we could see which one was the one that we were gonna go with.
Okay.
And then,
So we just give
Grace
them
was supposed to do the procedure, like Grace and Kendall, and she said, I'll have this, you highlighted, I'll have this in my notebook tomorrow.
Okay, so, but all of you remember yesterday were supposed to add to that procedure, so it wasn't, shouldn't have just been one person's job to do?
Yeah, she was
Okay, so I
supposed to do
guess
the
this
outline
goes
and we were supposed to.
we were gonna like.
So she was gonna outline it,
Yeah.
and then you were gonna add to it, okay, I understand now.
Yeah,
Okay.
like I had it written down that she was not Grace.
Really? Grace is here?
Is she back? Is she coming in?
She went around, I think.
Oh, great, okay, that's perfect.
Grace.
Awesome. Hi, Grace, they're waiting for you.
Grace.
Okay, that's great. Do you have the procedure with you? No. Oh, so it's up to Kendall? Okay, well, you guys work it out. Okay, so where are we at, Christine? Okay. Okay. Anything less than 7 would be considered acidic. But
pH.
you're just mixing that, no. With water. Yeah. Is this in hydrochloric acid?
Yeah.
Oh, no.
That's just gonna make it acidic.
No, right. Right. You're not measuring the pH of this. You're just checking, you're just seeing, you're stirring it. So did you, what does your procedure say? Let's go back to that.
pH with water.
Okay, so did you do all that already? Did you observe that reaction?
Yeah.
Okay. In either one, right? You did it in the acid and then you did it in the base?
No, we haven't done it.
Okay. Now remember, you can mix in these as well. All right? Watch your time. You've got 10 to 8 and you have a lot of tests to run through. So you might want to divide up.
What are the unknowns?
You don't do those until we get the knowns. You have to get your known data, remember?
Alright, so we just.
We have to get your known data so that we can compare it so that we can get our end.
She gets on the website.
Where are we at? Where's your copper 2 sulfate sample? This is just extra, but go ahead, you can use that. And you're stirring around from your group? You can use this one, but let's get it. Yes.
Are we testing pH just in water? Like,
That's go back and read your procedure and what you guys wrote, and
Okay.
then go back into the lab and see how.
okay.
Find that information from your reading.
Alright.
Are you part of RJ's group? Yes. Okay.
We were measuring.
You can use that one to Jasmine. They're all plugged in. Okay. So Ajay, you're stirring quite rigorously there. Tell me why you're doing that.
To get all the stuff from the bottom up.
Okay. Now remember when we did ionic compounds and we talked about how ionic compounds in water, what they do? Do you remember when we saw the video?
Yeah, they have to break down.
They do.
readily.
Okay, so go ahead and let's see how that works. They both have to be in the water or into the solution. You might want to move it around. Did you put 2 large scoops in there?
Oh, no, we already did.
Oh, it lit up.
Soluble
Did?
DNA.
It did. You see that?
Oh, I see the filament glowing. Not quite on, but yeah. Oh, you can see it.
Yep. Okay. Now you have to test the rest of your stuff.
Yeah.
Test your solids.
That's what you cross it out.
Okay, remember I said only one lab notebook in the lab? That you're just supposed to have your procedure in here? And then one person who's recording?
Could you just do it since we're both between like 2 different things?
Well, but you can report back to your person to be a reporter.
Well, who doesn't know this? We can just use mine.
Is this your data table?
We've contacted
Okay, what are you writing down?
pH done. We only need to finish solubility.
Oh, this is waste. These are waste figures. The conductivity you have to mix over here. Remember?
How much of the hexane slash alcohol?
30.
You need to bring again, if you want to bring your procedure, right?
We're looking for
Where's the alcohol at? And the hexane. Okay.
And because we already did conductivity pH and the reactivity with like acids or bases, I'm just checking to see if we did anything different that I didn't write down.
So tell me when you were writing this yesterday, when you guys were writing this yesterday and you're writing it out, it seemed like it was a little bit confusing because there was a lot of information there.
Yeah.
But now that you have it written out and you've come back and you've actually kind of started to work with the materials, what's different about that?
It seems a bit less confusing now, especially since we know last test what we're using.
You can see what form it's in, you can see how much of it you have. Okay, and that's one way that when you do go through the procedure the first time, you got all of the information out and you were able to kind of organize it a little bit. Now, going back, it's okay when you're doing something like this to revise this because you're doing these tests for known materials. When you go and do your unknowns, now you'll have a perfect procedure to be able to do. So it's okay. Good.
Yeah. I'll send it to you guys.
Okay, how are we doing? Oh wow, that's interesting.
Yeah.
In the sodium hydroxide?
Yeah.
Okay, the way speakers for it over there. What does that remind you of?
The lava lamp.
DNA. It does remind you of a lava lamp.
Whoa.
It's really cool that way, isn't it? So I'm going to ask you the question about this. Yesterday when you were all sitting and writing the procedure, and Ajay was kind of taking over the conversation, but you were all kind of talking about different things, about how you were going to put things in.
Yeah.
Now that you're actually doing the experiment, how is your procedure changing? What's going on?
Just different amounts of measurements and stuff.
Like visualize the amounts of change it to more.
Hey, Maury.
Okay, so you had to make it a little bit more, so you thought maybe this would be enough, but then you realize it's probably not too much. So because you're doing qualitative testing right now of knowns, it's good to perfect your procedure at this point. You're going to perfect it in a way that when you go to test your unknowns on Monday, you'll have everything done. So right now, it's okay to make those adjustments in your procedure and to get those in the place where you want them to be, so that when you get to your knowns, you'll just be able to read right through it and know exactly what your amounts are going to be. You won't have beakers like this that'll have the name on it. You'll have beakers like this that'll say substance A or substance B.
Then we put it in here.
Okay?
And then additionally, how do we do a conductivity of a solid? Do we just like put
Put it in here now.
That's exactly what you would do.
just put it in right now, solid?
Yep.
And the water.
No water.
No, yeah.
Great.
Oh, okay then. So do you
So now, because these are qualitative tests and you know what the knowns are, when you're going back through and you're making those adjustments on your procedure in that green pen, you're going to now have a really excellent idea of your procedure when you come in and do the unknowns. Okay? You'll do the unknowns on Monday. So once you get through all your knowns, then you're going to have to, who's going to be your rep that's going to go to the other groups? Do you have somebody? Oh, Grant's traveling? Okay. So are you all done with your unknowns? Or do your knowns? Okay, then go ahead and clean up, and then you can, well, go back into the reading and see what you need to do. Yeah, I'm going to send you, I always send you back to the text to find that information. All right, so go ahead and clean up. Waste speakers are in the center. So go ahead and kind of, you can rinse them in that distilled water over there. Feel free to just dump them in that sink, that's fine. That's fine.
Yeah, put this so
Did you test without the water?
yeah. Put it in the test tube and then just add
So how many do you have left?
1 drop.
Okay.
Yeah.
Awesome. Anything different from the other groups that you guys didn't get, that they got?
We didn't we weren't getting any reaction with acid or base.
Okay.
Like I went to that group and they said to test the reaction with acid or base with the water
With the water solution of it? Does it say to do that back in your lab? Okay, so. Well, it may not have been a reaction. Now, CuSO4, what did you notice?
Well, with the basic results, you change
Okay, so let's go back. Why don't you can redo it. Redo it and look at it. Take your sodium hydroxide and take your solid CuSO4 and put it in a test tube and see how that works. Because you tried it in the beaker, maybe the test tube would be a better place for you to do it. Doug, what are you noticing about what's happening in your beaker there?
Not coming off.
It's not gonna, so what was that from?
The paraffin.
The paraffin. And what do you think paraffin is? Ionic or covalent?
It's the opposite of water.
It's the opposite of water? Because it's not dissolving?
Covalent.
So it'd be covalent?
Yes, sir.
So I think what you need,
So done.
Dawn. Little Dawn dishwashing liquid.
Yeah.
Like dissolves like. This is why breed experiments are usually found out by mistake. Don't forget to, you gotta actually scrub it a little bit. Look at that.
So were we not supposed to dissolve it in water and then?
Ajay, go back to the reading. Always sending you back to the text. Tried and true.
One more
That helped. That you could actually put in your observations. That's something that you can add that you just saw happen. Right? Okay. Good. Make sure you close everything up. Is there any questions that you have to me? Do you have any? You're gonna do those on Monday. You're gonna do the same lab with the for Monday. So all your data tables done?
Yeah.
All right. So now what you need to do is you need to put it into that yes/no format. That is the dichotomous key. If this, then this, or if this happened, yes. If it didn't happen, no. And then you have to make a graphic organizer that shows that. So you're
This is
making
all on paper?
all on paper. It's going to be part of your lab report. It's in the rubric. Yep. Yep. It's all in the rubric. All right, you guys are done. You can go back and have a seat.
Oh, wait, so what happened? Wait, did we do this?
You know what? I'll touch it after class. Is everyone done with conductivity? Does anybody else have conductivity that they need to test? Solids or liquids?
We need to.
Okay.
Connectivity is right.
As soon as you're ready.
I didn't know what I had to
You need to bring your own beaker over there.
Oh, we gotta break that.
Ajay's group has quite a bit done, and these guys have quite a bit done.
We need a bigger.
You have your cabinets? Go ahead and take whatever you need out of the cabinets. Are you guys finished up? Sure about that? Good.
You do.
You guys are done with everything except this last test? Okay, now remember, the next part of this is to take your data results after you've compared them with everyone else, and then you have to write it in that yes/no
Between 4 and 5,
format.
just put
That dichotomous key format.
No, we don't have
Well, guys, we're not gonna finish.
Physical state, physical change, no. Anytime you dissolve something, it's just physical, physical change.
reaction with the food. Did we just do the powder?
How it's not gonna react.
Yeah, that fit. If it's.
Is it good?
Cool.
I just don't want to have to like.
Aiden, can you go get your speakers and your copper 2 sulfate over there? I'll use that. Because this copper 2 sulfate is a little bit.
What are you doing, Lauren?
I'm adding
This is gonna be Tuesday.
Yes, we'll talk about that on Tuesday. That should be good, Mark, because remember, you're just kind of giving it enough to dissolve.
got it. So,
Oh yeah.
it's like kind of chippy right now. What's up?
Well, you have to run it.
We're gonna test it. We don't know that yet. What? For what? This? I thought you already. Oh, what? Really?
Communicate. Did you already test it? Okay, Maureen.
Oh well.
Your group needs to have some better organization of who's doing what. Yes. Oh, good. Okay. Okay, so then you have to use about deionized water. Think about where.
Sit around.
Just take copies of the
Nope. Take 2 of those like cubes and test them
So
out.
that you can write it.
Yeah.
Okay.
So,
Yeah, she's so
get rid of this. Get rid of this.
Let's watch our time. We've got about 3 minutes. You should clean up wherever you're at this point. You can at least check in with the other groups. Go ahead and stop your experimenting at this moment. Make sure your lab stations are cleaned up. I'll have conversations with some of you after class about where you're at and where you're going to be for Monday.